Welcome to the video on dimensional analysis. This is video 1.5 in our Unit 1 series from Mr. Lawrence's Chemistry 1 class at East Central High School. This video is going to help you understand dimensional analysis. And when I say dimensional analysis, I really mean conversion problems. Conversion problems will use conversion factors. So this video, you'll use conversion factors to convert units from one material to another unit of the same material. Our key vocabulary terms are conversion factor and dimensional analysis. Dimensional analysis is a scary word, but it has a pretty simple concept. Dimensional analysis is really just a conversion problem. When you have something in a unit, a value of something in one unit, and you want to represent that same material and that same value in just simply a different unit. For example, 4 quarters equals $1. So I can represent the value as 4 quarters with the unit quarters, or I could represent the exact same value as $1. So it's the same value, it's the same material, it just has a different unit, being the dollar. A conversion factor is simply the ratio we use to relate or equate those two values. So again, a ratio is just equal amounts of the same thing, but with just different units. So for example, 4 quarters equals $1. 2.54 centimeters equals 1 inch. We're going to use this conversion factor in a minute to set up math problems to convert from one value of a substance to the same value, but just showing different units. But to the right, you will see a chart of useful common knowledge conversion factors. I will give you something like this for things that are kind of abstract or things that I don't expect you to memorize. However, there are a few conversion factors I do expect you to memorize, and I'll cover those as we go through here. Namely, 1 inch equals 2.54 centimeters is something that an educated person in the state of Indiana should know. So let's do a real simple idea here of a conversion problem before we move on and look at the steps of how to do more complicated ones. If I tell you you have 8 quarters, and I want to know the value of that in dollars, you all can use your head to say, well, 8 quarters divided by 4 quarters would give me $2. That is correct. Or I could say if you have $2, how many quarters is that? You would know to take $2, multiply it by 4 quarters to give you 8 quarters in $2. So a lot of this stuff is pretty simple in concept, but the problem is when we start to use complicated conversion factors and complicated relationships, and we have to have more than one conversion factor, we have to follow a process to be able to not get lost and to correctly get the answer and to know when to multiply or know when to divide those numbers. So these are 4 steps that we're going to use. I need you to commit these to memory. Again, these problems might seem simple, but they will get more complicated throughout the year. And if you don't have the foundation on how to follow the step-by-step directions, you will start to feel overwhelmed in the next unit. So trust me, follow the units, do exactly what I do, because there will be a mastery quiz on this that will grade you on your ability to mimic and to prove that you know exactly what you're doing every step along the way. So as we get using conversion factors to answer conversion problems, there are 3 phrases I'm going to say over and over again, and I need you to know these, and I need you to say these with me. The first one, write down what you know, follow your units, get a conversion factor. Let me say that again. You need to commit it to memory, because this is going to be the first question I ask you when you ask for help on how to do a conversion problem. Step 1, write down what you know. Step 2, follow your units. Step 3, get a conversion factor. And then simply we're going to use the math to solve the equation. So what I mean when I say write down what you know, you need to read the problem and determine the starting point. We often call this the given. What value and unit was given to you in the problem? Then you're going to follow your units. As we set up this math problem, we're going to be using fractions or ratios. So whatever unit you start with on the top of your fraction needs to go on the bottom of your next fraction or on the next step. And I'll show you what that means in a second. Step 3, there's a typo there, fixed. get a conversion factor. This is a ratio that connects your starting point's unit to the answer's unit. And sometimes you will see in the practice problem number 3 that we're going to do today, you might need more than one conversion factor. And then we're going to use math to just solve for the unknown. When we do these problems, we're going to multiply across the top and then we'll divide across the bottom. So here's problem 1. This is a thought process you should have in trying to answer dimensional analysis questions. The problem states, express the mass of 4.378 grams in milligrams. If you remember from the previous video, milli is a prefix and grams is the unit. So gram is a unit of mass, milli is a prefix representing 1,000. So your first step is to determine what is given to you, to be able to write down your unknown. Well, I determined the problem is giving me the value of 4.378 grams. And I'm going to look for an answer that's going to be in mass, but it's going to be in milligrams. So I'm in grams, that's my starting point. I'm going to end in milligrams. So the next thing I need to think through is what conversion factor do I need to use? And from the previous video, we should begin to understand that 1 gram equals 1,000 milligrams. If I get a true relationship here, now I can turn it into a fraction or a ratio, and as long as the left side of the equation equals the right side of the equation, I can turn that into a fraction where the top equals the bottom. So now let's see this written out. This is the thought process. I don't expect you to write all out, but this is more in line of what I expect to see. So we're going to start to set up our problem. So step 1, you should be writing down what the problem gave you, 4.378 grams. Step 2 is if grams is here, we will put grams down here. Now step 3 is we're going to get our conversion factor. I have 1 gram equals 1,000 milligrams. The reason step 2 is so important that I want to follow my units is because if grams is here, I'm going to put grams here. And then now when I get my conversion factor, that true statement, I can write 1 grams on the bottom and 1,000 milligrams on top. Again, this is a true statement. I am turning this into a fraction. All I'm doing is going to turn this into this fraction. Sorry, right here. So grams is on bottom because gram was here. So therefore I know to put 1,000 on top with 1 gram on the bottom. And then this right here will equal our unknown. So to solve the math, I would in my calculator put 4.378 grams, multiply by 1,000. The grams and the grams here would cancel out, and therefore my answer would be 4,378 milligrams. Another typo, sorry. All right, now let's do this together. I'm going to show you the thought process and how I would work this out and how I want to see you work this out. Step 1, write down what you know. Convert 3.54 feet to inches. I know the problem told me we are starting with 3.54 feet. To me, that is step 1. Step 2, you're going to follow your units. So get in the habit of setting up your problem. This is a multiplication sign. This is your line to divide, to show the fraction. I follow my units. I have feet here. Step 2 is follow my units. So feet has to go on the bottom. Whatever unit you start with has to go on the bottom of that second step or the second fraction. Now, step 3, get a conversion factor. If you remember from the video before, or the first few slides, we will know that 1 foot equals 12 inches. Now again, you might know this. If you don't know that relationship, you can always Google the conversion factor, or I might have it already given to you on the test. But if it's something as common as this, I do expect you to know it. So we can say that 1 foot, or 1 feet, I'm not in English class right now, so we can get away with this, is 12 inches. So all I did was set up my problem. If you like the way this looks better for your math skills, feel free to put a 1 under here. But since I am in my answers unit, I can put on the equation signs or hit the brakes, and the skid marks of the car will tell you you're done because you're hitting the brakes because you're in the right units. Now we simply just put this on a calculator where we are going to multiply across the top 3.54 times 12, and that is going to give me 42.48. Now in the next video, you will learn how to do significant figures, But the short answer here is, since there's 3 measured values in our original starting point, I can only have 3 values here, 3 measured values here. So the correct answer would be 42.5 inches. Again, this is the work I want to see exactly, and by the time you take your mastery quiz, I want to see exactly the correct significant figures in your answer. So now let's check out problem number 3. This is an example of when you need to be able to do 2 conversion factors in one math problem. So the steps are the same. The only thing you're going to do is repeat step 2 and 3 again. So step 1 is write down what you know. The problem says 34.77 meters. I'm going to write that value down. And I'm going to write an M instead of meters because I've already learned in the previous video that meters can be abbreviated as M. Step 2, follow my units. Meters here, meters has to go on the bottom. Step 3, get a conversion factor. If you would look back into the notes, you will see 100 centimeter equals 1 meter. I expect you to know this relationship. This was in the previous video, but I said in the video, centimeters, kilometers, centa, milli, and kilo, I expect you to start to memorize. And we'll practice this in class, and then you will commit that to memory very easily. But since I have meters here, and I see the relationship, I can go from meters to centimeters. So now at step 3, my conversion factor, I can begin to fill this out. When you do your conversion factor, remember, this has to be a true relationship, or in other words, the top of the fraction has to equal the bottom of the fraction for that to be a true statement or a true relationship. However, I am not done here. I want to go from meters to inches, and I only know to go from meters to centimeters. So I'm going to repeat step 2, follow my units, cm, centimeter to cm, and then now I know that 1 inch equals 2.54 centimeters. Again, this is something you can Google, or this is something you can memorize, or this is something I will give you, depending on the level of how difficult it is. But again, this is something that I think you should know. 1 inch equals 2.54 centimeters. So again, I am just going to fill in my numbers. 1 inch equals 2.54 centimeters. So all I did was I wrote down what the problem gave me to start. I followed my units, and then I got my conversion factors. 1 meter equals 100 centimeters. 1 inch equals 2.54 centimeters. So now we're just simply going to do the math. We're going to multiply across the top and divide across the bottom. So what that means, 34.77, multiply it by 100, multiply it by 1, and then we're going to hit divide by 1, and then divide by 2.54. If the number is on the top, you're going to hit the multiply sign before you enter that number in. If the number is on the bottom, you hit the divide sign before you put it in there. Now I hit my answer. I see here I got 1,368.8976. Again, Sig Fig says there's 4 measured values here, so my answer can only have 4 measured values. So I need to round to the single digit place. So my correct answer here would be 1,369 inches. Again, we will practice the Sig Fig idea in the next video. But right now, I want you to be able to write down what you know, follow your units, and get those conversion factors. So as we review again, all we're doing is using conversion factors to set up conversion problems. A few tips on this is dimensional analysis or conversion problems are like a road trip. The first thing we want to start to practice is just seeing what they give you in the problem, and then start to try to think about the process or the path that you would take to get to the answer, the destination. And then the more you use these, the more you'll be comfortable, and it should be pretty easy. Keep those conversion sheets handy. It will save you time on your homework and in class. And again, these prefixes you need to start memorizing. Milli, centa, kilo. Milli means 1,000, centa means 100, and kilo means 1,000. I hope you're able to do some conversion problems now. We will practice this more in class. Have a